Hello, this is Jeff Robertson, National Sales Manager for Penton Audio USA and Ateis Electronics. And this is a quick demo video on the popular component in our Ateis Studio software platform known as the voice gate. Now, what the voice gate is, it's a normal audio gate, so you have your adjustable threshold setting. You can bypass it, turn it on or off, as well as your hold time. But in addition to that, it actually has our own developed algorithm for recognizing the audio to determine whether it's actually a human speech or voice pattern above a lot of other random noises that are commonly run across in the conference room, council chamber / courtroom type of environments where there might be multiple microphones, and you don't want anything other than human voice getting in there. I'm going to do this as a demo so people can actually view this and see this working. As they probably heard my sales pitch a bunch of times, it's nice to actually see it working. I have a Ateis Studio. I'm already connected up to my demo machine right here, which is an ECS, which is most commonly used with multiple mic systems. And here's my design that I pulled out of it. So what I'm going to do is I'm going to go to my component list. Let me pull my components up here. There we are. We will go to dynamic in my component list, and in the dynamic component list is the gates. As you can see here in the gates, we got mono, stereo, gate with side chain, and here's the voice. This is our voice gate. I'll drag that into my design. Now, you can put as many of these voice gates into your system as you want. One thing to remember, they are what we call a smart component or an active component, which means it's constantly thinking whether it's being used or not. It's constantly determining, just like any gate would be. So, yeah, you start chewing up a little bit of DSP power as you start putting one on, but you can put one for every single input in your system. The microphone I have physically connected is a Crown CM150 reference microphone. I mean a true 20 to 20 kilohertz reference microphone. That way you know that I'm not using less expensive dynamic mic or whatever that has a lot of roll in on the bottom and a lot of roll off at the top. This is actually a true reference microphone. So any frequency is going to get in there that I can generate. And I'll just wire this to, I'll just say output 3 on the standard mixer, or input 3 on that standard mixer, which goes to output 3 over here. I want to go up here and compile my design, and we also want to store it into the machine. So there. Alright, our store is complete. Now we're into the machine and we should be running live. I am going to open up the input module, and you can actually hear me talking, and wow, I'm really pegging this thing out a little bit. So it's got a reference microphone on there, so there you go. That's a little bit better, I think. Alright, check 1, 2. I have a reference microphone, so I have phantom power turned on for that one input on my microphone. We will open up the output, so we make sure that, yep, here we are on output 3, because I just got it straight through the standard mixer, and you can see our output right there. That's a little hot. Let's move that down about -3. Check 1, 2. There you go. We're running about 0 dB, a little bit less than that. Alright. I am actually physically talking to you on my headset into the computer for recording, but I am probably 12 inches away from the reference mic. The mic is pointed in my general direction and towards my chest, so I'm not speaking directly into it. So I just moved it back a couple inches, and I just try to get a nice even 0. It looks about right there on the input, so I'm just looking at the input meter. Let's also open up the voice gate block. Now we can actually watch all 3. We should see this gate actually come on. So when this gate's on, that means it's actually active, and we're triggering the gate and audio's passing through, and we should see it on the output side. Alright, check 1, 2. As we can see, my input's active. We can see the gate is triggered while I'm talking. I've got a 2000 millisecond, or basically close to a millisecond hold time. Let's drop this down to about 1.2, 1.3, and you can see we got an output voltage. There's our signal presence and the meter going for our output levels as well. I'm talking, the gate is working as it should, right? All right. One thing on the gate, we have 3 different settings for the algorithm. Now this is actually the analyzation part of the voice gate: soft, medium, and accurate. The way I like to describe this: soft, it's going to reject some of the more harsher stuff, but it's going to let some stuff leak through. It's not quite as critical in its analyzation. Medium means it's right down the middle path, and then accurate means it's really going to be stingy about what it allows through there. That it really needs to know 100%. Yeah, that sounds like a voice pattern to me. I'm going to let it through and reject everything else. Really good in noisy environments. Let's just see the differences on these. Let's go to accurate, and we should pretty much block everything else but voice out. So I'm going to stop, let the gate go away, and then I will do some tapping on the table, and I'll start from the left of the mic, work my way right in front of the mic about 6 inches away, and get about a foot away. So there, as you can see, I was pounding pretty hard on the table, and the only time the gate would actually momentarily trigger on was when I got right in front of the microphone about 3 inches with my finger tapping on a wooden table, which the microphone is actually sitting on. I'm going to tap on the mic, and let's see what it does there. That was me tapping fairly hard right on the body of the microphone. That's a mechanical noise into the system, and the only audio was some of the low frequency that might have leaked through there from the beginning. Now I'm going to do some metal rattling. I will start about a foot away from the mic and work my way into about 6 inches away. So hopefully this will simulate some metal for the air handler, diffusers, and the ceiling or whatever that might be rattling up in the ceiling. As you can see, there was no gating whatsoever with the mic. Now, one of our more funnier and famous demos is I will actually use a snack bag, and this is one of my favorite. These are actually Lifesaver gummies. But I will rattle this bag. I will start off about a foot away. I'll work my way side by side and then closer to the unit, and we'll see if the actual rattling of like a potato chip or Doritos bag or whatever would gate the mic as well. Okay, so we saw there was one small little gate where it came on, and that's when I moved it directly in front of the mic and was doing it pretty heavily, and it overloaded it on the input as you saw, but at the same time it saw it, opened up, and then after analyzation real quick, it said, nah, that's not a voice, and then shut itself off, and then didn't come back in. So that's Doritos bag or whatever right directly in front of their microphone, not sitting in their lap. So let me run through them. I'm going to leave this on accurate. I'm going to tap. I'm going to mechanically hit it. I am going to rattle something and do the snack bag thing, and we'll see how it performs. There you go. Pretty impressive. Here's a couple other quick tests. I'll do some clapping and I'll do some snapping of my fingers. Even crack my knuckles right in front of the microphone. And you can see it comes on when I'm talking on my voice. That's the gift. Now I'll do the same test with the tapping, the mechanically tapping on the microphone, as well as the metal rattling and the snack bags. We'll do it on medium, and then I'll do it on soft, so you can see the differences and what can be picked up and what isn't, and the differences. So let's go to medium, and I'll conduct my test now. Alrighty, now let's do soft and see how the gate works on that. Okay, so you can see with the accurate, there's very little that can get through, and usually when it does, it analyzes and it learns it pretty quickly that that's not, and that's usually very loud, and the only time that the tapping and the snack bags really triggered the accurate was when I was right in front of it within like an inch or two of the microphone on a very sensitive reference mic, and it was overloading the input. The medium, it rejected everything except when I took the snack bag and was right in front of the microphone again and pretty much overloading it. Now on the soft, there was a couple of things. The tapping, when I got to a certain point, I think the resonance from the wooden table on the lower end triggered it. The metal clanging didn't trigger it. The snapping and the clapping really didn't trigger it. But the snack bag, when I got within about 3 to 4 inches of the microphone, it triggered it. So you could see the different analyzation that's going on with the voice gate. But you notice when I'm talking, the gate stays on. It comes on almost immediately. The slight delay you see visually is because that's the visual representation of the audio. But the minute it senses the audio signal, the gate comes on immediately, so you don't lose any syllables or begin a conversation. That is our extremely unique and very, very, very popular voice gate component demo. I hope you enjoyed. If you have any questions, please visit our website at www.penton-usa.com and have a terrific day. Thank you.